when the source of sound moves towards the stationary observer, source of sound moves towards the stationary observer, the wavelength of sound received by him. See here, the apparent frequency heard by observer according to Doppler's formula, Doppler's formula, what it said, apparent frequency heard by observer, it is actual frequency into V plus minus Vo upon V minus plus V minus plus Vs, V minus plus Vs. Whenever source is approaching towards the observer, use upper sign. So therefore, apparent frequency heard by observer when source is moving towards it is N dash is equal to N in bracket V plus Vo divided by V minus of Vs. Here we were given that observer is stationary, means Vo equal to 0. Therefore, apparent frequency heard by observer, it is actual frequency into V divided by V minus of Vs. V minus of Vs. This V minus Vs is less than V, means this ratio is greater than 1, means this apparent frequency N dash is greater than the actual frequency. Frequency heard by observer is greater than frequency actual frequency, and because V is equal to N lambda, it means frequency is inversely proportional to wavelength. So when N dash is greater than N, it means that lambda dash is less than lambda. So whenever observer is stationary, then the frequency of sound heard will be greater, while the wavelength received will be what? Less. So the wavelength of sound received by him decreases while the frequency increases. So out of 4 options, option A is the correct option for this question.